Hey people, welcome back. And in this session, we are going to learn about which hypothesis test we perform in what condition. So we'll be starting in the last session. I was explaining you that you need to first understand your data type. You need to check the normality. Then you will look for the centering or the dispersion and how many subgroup you are comparing. These four conditions first you have to meet. Now, which test we perform in what condition, I am going to explain you today. So let's say first thing when you compare, suppose you have some target value or standard value and you wanted to compare with the subgroup of the observation. You have the sample data and the target value you wanted to compare with. So the test which we perform here, suppose let's say I will be explaining you some 7 tests here. So the first test we perform the one sample t-test. And what is the prerequisite for one sample t-test? One, you are comparing the mean value. Your data is normally distributed and you are not worrying about the standard deviation of the process. You are not considering how much is the variation. So we consider standard deviation is unknown, right? So your standard deviation is unknown. So what you have the mean value you are comparing with the target value. Suppose target is 90% productivity you have to meet. Based on the last 20, 25 or 30 days data, what productivity is actually on an average is coming. You want to compare that statistically. Then we use the one sample t-test where the variability is not is concern for you. Now, in case variability is also concern for you, somebody is telling or client is telling, I am not looking only for the average value, but I am looking for something that average you should meet, but along with the standard deviation should also be controlled. In this case, your data is normally distributed and you have the mean value only compare. Then we will be using the one sample and Z test. Suppose you wanted to compare the mean, but data is non-normal. No, not this condition. Let's go. Another test first I will tell you. It's a one sample sign test first. We perform one sample sign test when instead of mean, I am comparing the median and my data is not normally distributed, where the standard deviation is not part of the picture. Alternate to one sample sign test, we have the one sample Wilcoxon test. And this test we perform to compare the median of a normally distributed data. Then we perform the one sample Wilcoxon test. In case you wanted to compare the standard deviation target with the observation, data normality or not normality doesn't matter here. It's not prerequisite. Then we use one sample variance test. You would say one sample variance or standard deviation test we perform here. In case you want to compare the defect rate, which means how many defects you have observed out of a population, data normality really doesn't matter here. Then we use one sample Poisson rate test. We will be using one sample Poisson rate test. In case you wanted to look for the defective rate, which means the proportion out of the total population. So when you are looking for the defective rate, then we will be using the one sample proportion test. So these are the tests we use when you compare the target value with the observation. Instead of this, if you have, suppose two observation data, two data set you have, which means you are observing one data set and you wanted to compare with other observation or the second data set. Then which test we use? So first thing, when you are comparing the mean of a normally distributed data and condition is before and after data you wanted to compare, and you have the equal sample size in both the cases, then in this case we will be performing the paired t-test. But remember, before and after only, and sample size should be equal in both the side before and after. In case you don't have the equal sample size, and maybe two data set you want to compare with each other, which may be before and after, or maybe any other two data set, process A, process B, or manager 1, manager 2, or maybe location 1 or 2. Data is normally distributed and you wanted to compare the mean, then we'll be using the two sample t-test. But before that, you have to check the variability of the data, which means you are going to compare the standard deviation. So in case you are comparing the standard deviation and data is normally distributed, then we will be performing the two variance test. And in two variance test, you have to give the information to the Minitab that my data is normally distributed. And based on that, it will give you the p-value of the f-test. In case you are comparing the variation of the data in form of standard deviation and data is not normally distributed, then we will be using the Levene's test. And this Levene's test again is a part of two variance test only. You just need to tick mark inside the options that my data is not normally distributed. Now, in case you are looking for the median comparison. So median generally we compare for the not normal data. Then we will be using the Mann-Whitney test. In case you wanted to compare the defect rate or the defective rate of your process, so instead of one sample poison rate test for the defect rate, for the two process, we'll be using two sample poison rate test. In case you are looking for the percentage, which is the defective comparison of two data 1 with the data 2, then we'll be using the two sample proportion, which is the defective rate test. So these are the sample. This is for one sample comparison with the target. This is for the two sample comparison with each other. And now I'm going to tell you that which are the tests we perform when you compare three or more than three sample with each other. So let's say you have 3 plus observations with each other. So 15, 16, 17, 18, 19. Okay. So first thing, we should be testing the normality. Based on the normality, we will be looking for the variation comparison. So in case you are comparing the standard deviation and data is normally distributed, then we'll be using the Bartlett test. Or if data is not normally distributed, then we'll be using the Levene's test only. Both the tests are part of test of equal variance. Both the tests are part of the test of equal variance. Okay. Now, after this, in case your data is normally distributed and you wanted to compare the mean value, then we will be using the one-way ANOVA test for three or more than three observation. And in case data is not normally distributed, you will be comparing the median value, which we will be using with the Moore's median test. In case your data is not normally distributed and you just don't want to compare the median, but you wanted to see the median rankings, then we will be using not only median but median ranking. Then we'll be using the Kruskal-Wallis test. These are the tests we perform for the 3 or more than 3 observation. Now, in case you wanted to compare the proportion of your data when you have the 3 or more than 3 observation with each other and you are comparing the proportion, percentage. Here we compare the variation, compare the mean, compare the median. So in this case, we will be using the test which is called as an chi-square test for the proportion comparison. Maybe 3 sometime, like as you have the 2 proportion test here which we had discussed, but when you have the data more than 2, then we'll use the chi-square. So first test here we use is called as an goodness of fit test. We use when y variable is your count and x variable is your categorical, part of the chi-square analysis. Then we use the goodness of fit test. You will be looking for the test of independence when your x variable is categorical and your y variable is also categorical. Both are categorical or both are count, because definitely text analysis cannot be done in the Minitab. So it will automatically count the all categories and it will calculate the proportion. So it can be count or it can be categorical, doesn't matter. The next test will be using, which is called as a cross tabulation. And cross tabulation we use when x and y both are categorical and you have a layer of z variable as well. Suppose you are looking for the defect. Defect is your y variable. Input variable is the type of machine. And then you wanted to create a layer of the shift wise. So you have got 3 variable. First you are observing the defect. From the different machine you are looking for the defect. And those defect is these machines are operating differently in the different shift, then we will be using the cross tabulation. Now, another test we use when your actually y variable is categorical and x variable is numeric. So your y variable category may be binary and x variable is your numerical variable. So like as you wanted to classify answer as an yes or no, good or bad or pass or fail based on some numerical variable, then we will be using the binary logistics regression. Then in case your variable is not binary, but you have the 3 category in a ascending or descending order, which we call as an ordinal data. X variable is still numerical, like as low, medium or high. And you wanted to classify that what are the probabilities that data will be on the low category or high category, like as you have the new employees are joining in the organization and they are raising a ticket. So based on how much time they spent in the organization, you are trying to find out that which severity ticket they are going to raise. So then we will be using ordinal logistics regression. Or in case your y variable is nominal, suppose employees are joining and you are asking them for the preference that which city you wanted to work based on their experience. So you wanted to classify as per the experience, what is the experience particular person is having and what are the chances that which city, which profile they would love to work. Then it is nominal logistics regression. And the last one, now this was about the logistics regression. And now we are coming to the main thing, which is very much applicable almost in every industry, in every kind of data, is called your correlation and regression. So correlation regression we apply when, so I explained you target with the observation 1 with the observation 2, then we are here 19, so this will be 20, 21, 22, this will be 23, 24, 25, this will be 26, 27, and 28. All right. So when your y variable is numeric in nature and your x variable is also numeric in nature, then we will be performing the, in case you are looking for the graphical relationship, let's say, like as visually graphical relationship you are looking, then you can just simply select the scatter plot. In case you wanted to see how strongly they are related, basically that is called as an strength of relationship. In case you wanted to identify how strongly they are related with each other, then we will be using the correlation analysis. And in the same condition, you wanted to predict, in case you know the value of y, you want to predict the value of x, or you know the value of x, you want to predict the value of y, then we'll be doing the regression analysis. So these are the tests as a black belt. You should know there are many couple of other tests as well, but maybe those are applicable for when you will go for the master black belt and all. In the next sessions, now I'm starting this series and I will be explaining you one by one each of the tests, how to, what kind of data you need, how to put the data in the Minitab, how to read the interpretation as a statistical, and then how to take a practical decision. Thank you so much, people, and I'll see you in the next session.